Hi, and welcome back. Today we are going to cover section 7.5, which is solving equations involving rational expressions. So there's a couple things that you need to note. I do have some notes at the very top of your page for you. However, let's jump right into the first problem so I can explain what's going on, so we can see where it is. All right, so I have 7 minus 6y is equal to 9. Now, anytime I'm dealing with an equation such as this with a rational expression, I always have to check my domain because something may not be included within my solution set. And that would be a value that can make my entire world implode. I'm dividing by 0. You don't want to do that. So what we're going to do is we're going to look at all of our denominator values. In this case, I only have 1. And I'm going to set it so that y cannot equal 0. So I'm taking my denominator value, setting it so that it cannot equal 0 like I did before to find my domain. In this case, this is already simplified, so I know my domain is everything except for 0. Okay, very good. So I start with my domain. That's number 1. Number 2, as we're going through this problem, we need to make sure at the very end that our solution works. So let's go ahead and solve. I currently see that I have 7 minus 6 over y is equal to 9. I'm going to move this 7 over just because I can. So subtracting 7, that means I have a negative 6 over y is equal to 2. Now, how many people love fractions? Yeah, that's what I thought. Let's go ahead and clear those fractions. Let's multiply by the LCD, which is going to be y to every side here. That cancels my fraction here. That's a negative 6 is equal to 2y. Divide by 2, y is equal to a negative 3. But wait, there's more. Yes, you got to a solution of y equals negative 3. However, you must check that this solution works. Here's how we check it. Y is equal to negative 3. Does it work? Well, I said that y cannot be 0. Y can be anything else, so y equaling negative 3 is okay. So you do have to go through and find the domain, understand what it is that cannot be included, solve your problem, then check your solution against your domain. That's the whole process. Let's go through another one. And I'm going to erase this just because I want my board space back. All right, so I have second problem, 5 over 4x minus 9 is equal to a negative 1. That is a minus 9. I'm going to write that a little more clearly. There we go. So I have 5 over 4x minus 9 is equal to negative 1. First things first, let's find that domain. So I have 4x minus 9 cannot equal 0. Solving this out, add 9 divided by 4, x cannot equal 9/4, meaning I can be anything else. So I know this little tidbit is what I have to come back to. All right, that being said, let's clear that fraction, multiply the LCD, which is 4x minus 9, to both sides. That cancels this out here. I'm left with 5. On this side, I have a negative 4x plus 9, because I have negative 1 times these values. It's changing my signs. Move my 9 over, so that's subtracting 9. That's a negative 4 is equal to a negative 4x. 4x is equal to 1. Check it. Can x equal positive 1? Yes, because x cannot be a 9/4. There we go. Very good. Let's get some more board space. And let's make the problems a little bit harder. So let's say I have 6 over 5x minus 2 over 3x is equal to a negative 8 over 45. Now, in this case, I have x's in multiple places in my denominator. So I still need to look at my domain setup. I'm going to erase this side just to give me some board space so we don't actually interfere with this problem. But I would have 5x, so it cannot equal 0, which means x cannot equal 0. That's my first denominator. My second denominator is 3x cannot equal 0, but hey, I get the same exact thing of x cannot be 0. So that actually works out very nice in this case. 45 is a constant value, so I don't have to worry about it changing. Now that we know what our domain check will have to be, we can then go through and solve our problem. How do we clear the fractions in this case? Well, what is my LCD? 5 can go into 45, 3 can go into 45, so that works out nice. These have an x, but this one doesn't. Okay. So let's say that my LCD is 45x, just to clear everything. So I'm going to multiply everything here by that 45x. 5 goes into 45 9 times, so that's 9 times 6. X cancels. Minus, I have 2 times, x cancels. 3 goes into 45 15 times. Looking good so far. 45 and 45 cancels. I have negative 8 times x. So we cleared our fractions. That's very nice. At this point, let's simplify. So 9 times 6 is 54. Minus 2 times 15 is 30. Is equal to a negative 8x. 54 minus 30 is 24. Divide by negative 8. X equals negative 3. And we're done, right? No. Check it. So x equals negative 3. Is that possible? Yes, because x cannot be 0. There we go. So x equals negative 3 is true for that statement, for that equation. Let's try another one. And again, I'm going to erase this just to give me some board space. I am on example number 4 here. So this is 5 is equal to 4x over x minus 3 plus 7 over x. Okay, very good. So at this point, I have x's in multiple places. We're going to go ahead and get our domains. So I see that x minus 3 cannot be 0, which means x cannot be 3. And I see x cannot be 0. So I've got 2 values that I have to check against. So keep that in mind. Now, let's go through and solve. What is my LCD? X minus 3, right? So I'm going to multiply by that LCD of x minus 3. That's going to give me 5x minus 3. Come back to distributing that in a moment. X minus 3 cancels here. That's 4x times x plus x cancels here. That's 7 times x minus 3. So we've cleared our fractions. Awesome. Let's distribute. Let's simplify our stuff here. So that gives me 5x squared minus 15x is equal to 4x squared plus that's 7x minus 21. Okay. And it looks like I have something that might have to factor. Let's get everything over to the left side and set this baby equal to 0. Let's see what happens. So I have this x squared term on both sides, and that's the rationale I'm using. So I'm going to move everything over here to keep that x squared positive. So 5x squared minus 4x squared, I get x squared. Negative 15x minus 7x is negative 22x. Adding my 21, and I am equal to 0. Well, yeah, it looks like I can factor that, so let's go ahead and factor. So I have x. Factors of 21 that might give me 22. Well, how about 1 and 21? Signs are the same. They're both negative. So then at this point, I have x minus 21, jumping the gun here, is equal to 0, or x minus 1 is equal to 0, pulling out that zero product property again. Solving this, I know x can equal 21, x can equal 1. But check it. Can x equal 21? Yes. Can x equal 1? Yes. So both of these are good. I have 1 and 21 as potential solutions for x. And that's it. All right. We are on a roll. So let's keep rolling. That was number 4. We're on number 5. Okay, so I have 5 over x minus 2 minus 2 over x plus 2 is equal to 3 over x squared minus 4. Whew. Lots of stuff going on here. I am going to erase this other problem just to give me some board space because it looks like we're going to need some board space. So, there we go. Now, looking at this problem, I see I have an x minus 2, I have an x plus 2, and I have an x squared minus 4. This looks like it could factor. Let's go ahead and break that down. So that's x plus 2, x minus 2, because it is a difference of squares. I'm using that shorthand where I just factored below, and I crossed out the x squared minus 4. Now, what is my LCD? Looks like that x plus 2, x minus 2, right? But before I jump into that, I need my domain. So I have x plus 2 cannot equal 0. X minus 2 cannot equal 0, which means x cannot be either negative 2 or 2. That's my check. My LCD being that x plus 2, x minus 2, I'm going to multiply everything here by x plus 2, x minus 2. X minus 2 cancels here. That's 5 times x plus 2 minus 2 times the x plus 2's cancel. That's x minus 2 there. X plus 2, x minus 2 cancel completely, so that leaves me just 3. At this point, you want to go ahead and distribute your terms, simplify everything that you have. So this is a 5x plus 10 minus 2x plus 4. Notice that sign change there. Is equal to 6. Or so, it is not equal to 6. I don't know why I distributed. Don't look at that. That is equal to 3. Okay. Little things as you go too fast, right? All right. Now looking at it, I have 5x minus 2x, that's 3x. 10 and 4, that's 14. That's equal to 3. I'm going to move my 14 over. And so that gives me 3x is equal to a negative 11. Divide by 3. X is equal to a negative 11 thirds. Does that work? Well, it's not negative 2 or 2, so yes, that will work. Okay. Wow, we're on example 6 already. Let's get some board space up here just so we don't interfere. And I got plenty of space, yeah. So I have 1 over t plus 3 plus 4 over t plus 5 is equal to 2 over t squared plus 8t plus 15. Whew. Looks like I got a lot going on there. So first things first, let's see if we can factor out this, our little trinomial at the end. So if I can factor that down, I have t and t. 5 and 3 give me 15. Signs are the same, and they're both positive. Does that work? That's 5t, that's 3t, that can give me 8t, sure. Go ahead and cross that out. Now my domain value, I have t plus 3 cannot equal 0. I have t plus 5 cannot equal 0. So I know that t cannot be a -5 or a -3. So that's what we're checking against. All right, let's take that LCD, which is t plus 5, t plus 3, and multiply it against everything. When we do, t plus 3, t plus 5, t plus 3 cancels here. That's 1 times t plus 5, or just t plus 5. T plus 5 cancels here. That's 4 times the t plus 3. The entire denominator cancels here, so that's equal to 2. Let's distribute and simplify. So that's t plus 5 plus 4t plus 4t plus 12 is equal to 2. That gives me 5t plus 17 is equal to 2. 5t is equal to a -15. T is equal to a -3. Cool. I'm done, right? Wrong. You got to go through and take this value and check it. T cannot equal -3. What does that mean? Well, this is not going to work because we're saying t equals -3, but t cannot be -3. What does that mean? That means for us that there are no solutions. And that's it. Leave it just like that. No solution. Boom. Okay. So as you're going through this process, again, you're always going to check for your domain first. Sometimes that means you may have to factor out one of your denominators, and that's okay, just to see what components you have. But you're going to check for your domain first, solve your problem, then check your solution, because sometimes the solution doesn't fit, which means you have no solution at all. Okay. Now this next little part of 7.5 is really just more of a refresher on how to work with general equations or formulas. So if I have something like 1 over a plus 1 over b is equal to 1 over x, this is actually an optics formula. If I were to take that and I said solve for a, and really you could be solving for any variable, but in this particular problem we're solving for a. What would we do? Well, yeah, you'd go through and look at this problem and say, where is a? It's in the denominator. How do I clear my fractions? I need an LCD. What's my LCD? A, B, and X, right? Because that's all three of my denominators, and I don't know what they are, so it's all three. So I take my LCD and I multiply it across. A cancels out here. That leaves me BX plus B cancels out here. That leaves me AX is equal to X cancels out. That leaves me AB. Very cool. Now where is A? You have to always ask that question. If you're searching to solve for a variable, then you have to be able to find where that variable is. A just happens to be in two different places. So we need to do a little rearranging. Let's get our A's to the same side. So that's BX is equal to AB minus AX. How do I get A out from both of these? Well, it looks like it's a GCF to me, so I'm going to factor it. So I have A times b minus x. This side didn't change, it's still bx. Okay, I'm only concerned with a, so since this is being multiplied, I'm going to divide by b minus x to both sides. And so I have bx over b minus x is equal to a. Did I solve for a? Yes, leave it alone. You're done. That's it. Finito. All right, let's try another one. T is equal to 2u. That's a big U, capital U. T is equal to 2u over b plus e. Talking about a thermal problem here. And we're solving for b. B is right here in the denominator. I need to clear out my denominator, so let's go ahead and multiply by my LCD, which is b plus e. And it sounds like alphabet soup. Okay, so we're going to go ahead and multiply by b plus e to everything. This is b plus e times t. This side is 2u, because the b plus e would cancel out. Now, there's a couple different things that you can do at this stage, and I will actually show you the second way of doing this in just a moment. But the first thing that probably pops to mind is, hey, let's distribute, right? So you get bt plus et, et is not phoning home, and you have that equal to 2u. We're going to subtract et, so bt is equal to 2u minus et. And then I'm going to divide by t, because I don't care about t, I care about b. So that means b will equal 2u minus et divided by t. And that's it. So that works. But let's go back for a moment. What if I'm looking at this same exact step, and instead of distributing, what if I divided that t? How would that be any different than what I'm doing? So let's say I have the same exact step. I'm just going to rewrite it. Same exact step. I'm going to instead divide by t instead of distributing it. So dividing by t, that leaves me b plus e over here is equal to 2u divided by t. Subtract e, I have b is equal to 2u over t minus e. This and that look a little bit different, but they say exactly the same thing. So either solution here is correct. Both of these are exactly the same. And just to prove it to you, if you were to think about this particular solution, technically you could have 2u divided by t minus et divided by t, right? Because you could split up the t to each of these. It's a polynomial divided by a monomial. The t would cancel there, and what are you left with? 2u over t minus e. It's the same exact thing. Now, either solution here is perfectly acceptable. So no matter how you approach this problem, it is perfectly acceptable with either solution set. Okay, so ladies and gents, that's all we have for section 7.5. It's a lot of information. I highly suggest going back, reviewing this very carefully, because this is quite a bit of a process just for the general equations, but especially when we were solving for the rational expressions within an equation. Okay, guys, that's all I have. I'm going to continue with section 7.6 in another lecture, or as soon as you click play.